Welcome everybody back to Number Sense Academy, and in this video we're going to look at distance of a line segment, or the length of a line segment. Same thing. So in other words, we could go from 2 points in a line segment, so two endpoints. So if we have two endpoints, we can calculate the distance, or we could just simply calculate the length. It's the same idea. So we want to travel or determine how far it is to travel from point A to point B in the Cartesian plane, or we could just find the length of the line segment. It's the same thing. So let me just be more specific. So in this video, we're continuing with line segments, but we're looking at distance or length. Same idea, just it might change from context to context. So if we just journey back for a bit, we understand that a line segment has two endpoints. Could be A, could be B. So what we're concerned with is how long or how far is the distance between point A and point B, in the case of maybe traveling from one city to the next. That could be a representation of distance. So going from one city to another. All right. Or you could just be interested in the length of two endpoints. Okay. So a couple properties. We know that the line segment, the length is it's fixed between the endpoints, and we just have to determine what that value is. And the important thing, remember that a line segment, it's just a part of a line. So if I have a line that's, say, continuous, and these arrows tell me that it's continuous, I could chunk it out into lines or segments of the line. Right, so there's one segment of the line. I just made that blue. And then there's another segment. And the segments could be different lengths, could be different distances. And because it's a segment of a line, it's still going to have the properties of a line. So it has slope, right, which is also known as steepness. And it has direction, okay, which could be it slopes upwards to the right, or it could be downwards or downward to the right. So let's jump quickly into the formula for finding the distance. So the formula is d is equal to, we're going to take the square root of the difference between the x values. We're going to square those, and we're going to add it to the difference between the y values, and we're going to square those. And then the last step we do will be the square root. So let me just reiterate. The first thing we do, we're going to find the difference between the x values, and then the y values. Then we're going to take that difference and we're going to square them, right? And then the third thing we're going to do, we're going to add those values. And then the last thing we'll do, we'll take the square root, and that will give us the distance between the 2 points. All right, let's just jump into a quick example then. And for this one, for this first example, I won't do anything on the Cartesian plane. We'll just jump right into it. So suppose we have a point A at -2, 7, and then we have a point B at 4 and 3. We want to find the length of the segment. All right, so first thing we're going to do, we're going to write down our trusty formula. D is equal to, we're going to take x2 minus x1, we're going to square it, and we're going to take y2 minus y1 and square that. Now, this is something to be cautious of. Your x2 and your x1 needs to be consistent. So I'm going to say this is x1, so that would be y1. This will be x2. This will be y2. Now, let me just double check. No, they don't need to be consistent actually because of this. Because you're squaring. It doesn't matter what order you put them in. And I'll show you what I mean. So if I say negative 2 minus 4 squared, that's going to be negative 6 squared, which is 36. Okay, so if I switch the order and I go, so what do we have? So this is my x1, this is my x2. Now I'm going to switch the order. So if I go 4 minus 2, that's going to be equal to 4 plus 2, which is 6. And I square it, I still end up with 36. And what you notice is that I switched the order. So this is x2 and x1. Still gives you the same thing. So there's no, just like the midpoint. Remember the midpoint, the order didn't matter because you're adding. Well, in this case, the order doesn't matter because after you subtract, you square it. So that's what we get. That's what we get away with. So let's work this out. So let's plug our values in. We have x2 is 4, x1 is minus 2, so I have 4 minus 2, and I'm going to square that. I'm going to add it to 3 minus 7, I'm going to square that. If I do this step by step, 4 minus 2, that's going to be 6. And then I have 3 minus 7, be negative 4 squared. So I have 6 squared is 36. Negative 4 squared is 16. So now I have the square root of what looks like 52. So if you plug that in on your calculator, just find the square root of 52. Should end up with something approximately 7.21. We'll just leave it at 2 decimal places. So very straightforward. Let's look at another example. We want to calculate the distance between the line and the following point. Actually, no, let's take out the following. I don't need the following. We actually need more information. So the line is y equals 4x minus 2. And the point negative 3, 3. Okay, so we need to find the distance between the line y equals 4x minus 2 and the point negative 3, 3. So whenever we see these, I'm going to put this on a graph because there's some information here that we need to understand. So let's get this on a graph real quick. X. So let's first put this on a graph. So for this one, we know that the y-intercept is 0, negative 2, and m equals to 4 over 1. So let's graph that. Okay, so 0, -2 is right here. And then we're going to rise, let's make that red. I'm going to rise 4 and run 1. So 1, 2, 3, 4, and then here. 1, 2, 3, 4, and then here. So I have, pardon the poor sketching. Okay. And then now we have the point -3, 3. -3, 3. So this is 1, 2, 3, so -3, and then so that's about here. All right. So we want, if you look at this closely, the closest point, or the, yes, so the closest point on this line to this line would be to where these two lines are perpendicular. All right? They are perpendicular to each other. Okay? So there's a couple things that we have to do to figure out the distance. So we know that this is already 3, so this is -3 and 3. What we need to figure out now, we have this point. We need to know where this point here intersects this line. And we know they meet at a perpendicular point. So we need to find out the point where they meet. In order to find out the point where they meet, we first need an equation for this line. And how can we find that? Well, we're given the point, and we know that all we need is a negative reciprocal slope of, I'm going to call it line A. So let's get the negative reciprocal slope, and then we're going to call the other line line B. So the negative reciprocal slope is, so if the slope of A is 4, then the slope of B, line B, is going to be -1/4. So now we could use this information to figure out what the equation is. Then we can find their point of intersection. Once we find their point of intersection, then I could use those 2 points and I could find the distance or the length of the line. So let's do that. So let's first find the equation of B. So we're going to have y minus y1 equals m times x minus x1. So y minus 3 is equal to -1/4 times x minus -3, which is x plus 3. All right, so what do we have? So now we have y minus 3 equals -1/4 x minus 3/4. And this continues to be y is equal to -1/4 x minus 3/4 plus 3, and 3 minus 3/4 plus 3 is going to be, so this is going to be 12/4. So 3 is equal to 12/4, and then 12/4 minus 3/4 equals 9/4. So plus 9/4. Then we're going to take these two equations and set them equal to each other so we could find out the point of intersection. So I'm kind of jumping through this. So we know that the point of intersection is where these two equations meet. So let's go with y No, let's not go with y. Let's just set them equal to each other. So we're kind of blazing through this a little bit. If you're not comfortable with how fast we go through this, then check out the video on substitution or elimination, or both. So we have 4x minus 2 equals negative 1/4 x plus 9 over 4. Right? So we have 4x plus 1/4 x equals 2 plus 9 over 4. All right. So there's a whole lot of activity here. So this is going to be 4x plus 1/4 x is actually going to be 17 over 4x is equal to, and then 2 plus 9, so that's going to be 8 over 4, which is 2. So now I have 17 over 4. So if I divide 17 over 4 on both sides, I get x is equal to 1. So now I could use x equal to 1 and sub it into the equation. I'm going to sub it into this equation. It's easy to work with. And what I have is y is equal to 4 times 1 minus 2, which is 4 times 1 minus 2, which is equal to 2. So the midpoint, so that coordinate becomes 1 and 2. So now I just need to find the distance between 1 and 2. And I'm going to try and generate some real estate here to get this done. So I have the distance. So remember, the points I'm using are 3 and 3 and 1 and 2. So it's going to be, so the x's are 1 and negative 3, so it's going to be 1 minus minus 3 and then squared, and the y's is going to be 2 minus 3 squared, which is equal to the square root of 1 plus 4, or 1 plus 3 is 4 squared, which is 16, plus 2 minus 3 is negative 1. Negative 1 squared is 1. So I'm taking the square root of 17. And if you plug that into your calculator, you get about 4.12. Right? So there's a couple things that you could pull from that. Again, working with these equations, you really need to work with the information that you have. One of the key pieces is that the shortest point from a point to another line would be where they meet perpendicularly. Everything else is going to be a little bit extended, and I could show many ways to show that these, if it's not perpendicular, then we start creating these diagonal lines, and now they become further and further away. Okay, we can't just jump to the midpoint because we don't know if it's actually meeting it at the midpoint. You can only find the midpoint of a line segment. You can't find the midpoint of a line. Okay, so therefore we have to use the information we have to determine the equation of the line, find where they intersect, and then use that point of intersection and couple it with the point that we were given, and then use that to find the distance. And that's how we end up with 4.12. Thank you.